We have discussed different methods of corrosion control. Few among them are metallic coating, anodizing in our previous session. So now we are going to discuss one of the major method, cathodic protection. So how does corrosion occur? Corrosion occurs mainly due to movement of electrons from anode to cathode. So if we supply electrons to cathode from an external source, or if we convert the anodic sites to cathodic sites, we can prevent corrosion. So the main reason why corrosion occurs is, that is electrochemical corrosion. When two metals are in contact with each other, one metal acts as anode, other metal acts as cathode. The metal acting as anode undergoes oxidation, supplying electrons to the metal which is acting as cathode. The metal which is acting as cathode will be protected or safeguarded. So if you want to protect the metal is acting as anode, or if you want to prevent corrosion, then we are supposed to prevent the anodic reaction. So how to prevent the anodic reaction? We are supposed to supply the electrons to cathode from some other external source, or convert the anodic sites to cathodic sites. So the technique of protecting the specimen from corrosion by providing electrons from an external source or converting anodic sites into cathodic sites is known as cathodic protection. There are mainly two types of cathodic protection. They are sacrificial anodic method and impressed voltage method. Let us discuss this one by one. Firstly, sacrificial anodic method. Here, metal to be protected, as we call a base metal, is converted into cathode by connecting it to a metal which is anodic to it. So metals like zinc, magnesium, which are more active than iron, are as used to supply electrons to the specimen, thereby converting the anodic sites to cathodic sites. Since anode undergoes corrosion, protecting the specimen, it is called as sacrificial anodic method. So this method is usually used to protect ships from corrosion, oil pipelines, etc. So this can be better understood by taking an example. Let us take an example where ship is sailing in the sea. So as we all know, ship is made up of a metal. So usually ship will be made up of either iron, right? So and we have also discussed, you all are well aware that, so since ship is made up of iron and the rate of corrosion is very high in saline water, because the conductivity is also high in saline water. Salinity, conductivity and corrosion are directly proportional to each other. So by the time ship sails from one shore to the other shore, what should happen? The ship should sink. Why it should sink? Because here in the ship, what type of corrosion occurs? Differential aeration corrosion occurs. So once the corrosion initiates, a hole will be formed. Because of that hole, water penetrates into the ship and the entire ship should sink. But that's not the case. Till now, due to corrosion, none of the ships have sunk, isn't it? So let us see how to prevent the metal or the ship from undergoing corrosion. So the ship will be sailing on the water. Part of ship will be below water. The ship is made up of iron. So The metals which are above iron will act as anode. The part of ship which is below water acts as anode, and the part of ship above water acts as cathode, and corrosion will be initiated as we have discussed in our differential aeration corrosion. So you're supposed to protect the part of ship which is below water, right? Since it's acting as anode by sacrificial anodic method. So how do you protect? So you're going to connect it with a hull. So what do you mean by hull? So in order to tie the ship in the seashores, we'll have a L shape, a hook. It will be connected to the ship. That is called as hull. So that will be usually made up of either zinc or magnesium. As soon as you connect it with zinc or magnesium to the base of the ship, so until now the base of the ship which is acting as anode will get converted to cathodic side, because zinc is higher in electrochemical series than iron. So now zinc starts supplying electrons to base of the ship which is acting as cathode now. So zinc starts undergoing corrosion. When zinc undergoes corrosion, so what will happen? Slowly zinc corrodes or dissolves. So once zinc starts corroding, what will happen? When you have a small part of the hull, you're going to remove that hull, throw it, you're going to attach. So in order to protect the base of this ship, the zinc is sacrificing itself. So since zinc is sacrificing, and since zinc is an anode, it is called as sacrificial anodic method. The same method is used in oil pipelines. So oil pipelines is usually made up of iron. So above that, you are going to put a small thin layer of, or a pencil or a pen, this thickness layer of zinc or magnesium. Until zinc and magnesium is in contact with oil pipeline, the pipelines are safe. It's not necessarily the oil pipeline, it might be even gas pipeline to be precise. So what are the advantages of the sacrificial anodic method? It is installation cost is low maintenance, and simple method. So our next method is impressed voltage method. So what do you mean by impressed voltage method? So it's a method of protecting a base metal by applying current larger than corrosion current. In this method, electrons for protection are supplied from DC power source. So here, as you can see in the diagram, the metal to be protected is made as cathode. Inert metal, it might be either graphite or carbon, is made as anode. It is connected to the, that is below earth, it is connected to a power supply, that is DC power supply. So when you connect it to a DC power supply, external power supply as shown in the figure, so as anode is an inert metal, so what happens? At anode, oxidation occurs, or it does not undergo any corrosion. You are supplying the power, electrons. So the anode does not undergo any corrosion, or it does not react itself since it is inert. So since the metal to be protected, this tank, acts as a cathode, you are supplying electrons to that. So since you are supplying electrons to the tank or the metal to be protected from corrosion, until and unless until the electrons are supplied, the metal is safe. So here you are supposed to take care that the corrosion is the electrons are distributed equally throughout the surface. If the electrons are not distributed equally on the surface of the base metal, for instance, you have taken tank as the example, then galvanic cells, minute galvanic cells will be formed on the surface of the structure to be protected, and severe corrosion might occur. So such type of corrosion control is usually seen in oil tanks, water tanks, oil pipelines. The best example for this, or in reality where you can observe this, is in your petrol pumps. So any petrol pump you visit, there will be a separate place where you can see this The tank will be, all the petrol tanks are underground. The top of that lid where we get a petrol from various sources. So they're going to fill in that. Everything, the tanks will be buried under the earth in order to protect the entire structure of that, whatever you're going to store the petrol. It might be petrol or diesel. It is an iron structure. In order to prevent that from undergoing further corrosion, you're going to supply impressed voltage. Advantages: low maintenance, so it is one installation and can protect large area. As I discussed earlier, so the major disadvantage is impressed current should be uniform, or else localized corrosion will occur. Thank you.